For 12, which statement about abstract classes and interfaces is false? A, an interface cannot implement any methods, whereas an abstract class can. B, a class can implement many interfaces but can only have one superclass. C, an unlimited number of unrelated classes can implement the same interface. D, it is not possible to construct either an abstract class object or an interface object. So all of these are true. And all of the methods in both an abstract class and an interface are public. That's not right. You can have private methods in an abstract class. So E is the correct answer. So for 13, we have a cute little diagram of the hierarchy of classes. A program is written to print data about various birds. And so we have the print name, print bird call, and then a lot of constructors. And so assuming that none of the given classes is abstract and all have default constructors, which of the following segments of more code right here will not cause an error? So print name parrot2, which is constructed as a parakeet, which inherits from both of these. So the thing here is that parrot, as its parrot2 is constructed as a parrot and it's not a bird, so the compiler is unhappy. So print name parrot of bird1, that would cause a class cast exception. See print name bird2, which is a bird, and then print bird call of bird2, which is a bird, but it also has the data of a parrot. The only thing is that it isn't casted as a parrot, so it doesn't work out. So for this one, print name of parakeet, parrot1. So unfortunately, parrot1 is a parrot, and so can't have its name printed. Let's see, 13. Yeah. So E, print name of owl, parrot2. So parrot2 isn't an owl, it causes a class exception. So I actually made a mistake with C. It turns out you can, you don't need to cast bird2 here because it has all the data for parrot. It just basically checks if there's a parrot in there. So you might get a compile time warning or something here, but it would still work. So C is the correct answer. So for 14, refer to the classes below for questions 14 and 15. Public class A with a constructor, and method 1. Public class B extends class A, public void method 1, public void method 2. So the method 1 method in class B is an example of A, method overloading, B, method overriding. So we've kind of already been over this question. It's B, it's just overriding this method. So for 15, consider the following declarations in a client class. Class A ob1 equals new class A. Class A ob2 equals new class B. Which of the following methods will cause an error? So ob1 dot method 2. So class A, if we look up here, does not have a method 2. And it's constructed and initialized as class A. So method 2 can't be called on that one. For 2, OB2 is a class B, but the thing is, it's not casted as one. So the compiler will have issues with that. So in 3, we have both of the things correct. Actually, this would cause a class cast exception. Yeah, so 1 and 3 will actually cause an error. This one is fine. I always get a little bit confused about polymorphism, but again, this is one of those cases where a compiler might give you a warning because you're not giving it this class B cast, but since it actually is a class B, it ends up being fine. Whereas 1 and 3, OB1 is not a class B, so that's a class cast exception. And then 1, it just doesn't have method 2. So 1 and 3, D is the correct answer. So for 16, use the declarations below for questions 16 through 18. And so we have a solid, a sphere that extends solid, a rectangular prism that extends solid, and a program that tests these classes has the following declarations and assignments. S1 equals new solid blob. S2 equals new sphere, sphere 3.8. S3 equals new rectangular prism, box 2, 4, 6.5. And S4 equals null. So we have to go up and check all of the constructors. So the solid constructor is right here. The sphere constructor is a string name and a double radius, so that's fine as well. And then a rectangular prism, it has a string and 3 integers, or 3 doubles. So that's also fine. 16. And then S4 equals null. So these 3 are correct as well as this one. But the thing is with this one, solid is an abstract class, and you can't instantiate an abstract class. So that line is incorrect. So A is the answer. Moving on to 17. Which is false? If a program has several methods declared as type solid, the decision about which volume method to call will be resolved at runtime. If the solid class were modified to provide a default implementation for the volume method, it would no longer need to be an abstract class. If the sphere and rectangular prism classes failed to provide an implementation for the volume method, they would need to be declared as abstract classes. The fact that there is no reasonable default implementation for the volume method in the solid class suggests that it should be an abstract method. So all of these are true, just true things about, like facts about abstract methods and just abstract classes. E, since solid is abstract and its subclasses are non-abstract, polymorphism no longer applies when these classes are used in a program. And polymorphism does apply, like always. So E is the correct answer.